Kia ora and welcome everyone. This is the Engineering New Zealand hosted Changes to the Earthquake-Prone Building System webinar presented by EPB. We've just started. We'll leave it a minute or two to let everyone join. We've had a very large number of people sign up, so it may take a wee while for people to join. Kia ora and good afternoon, everyone. This is the Engineering New Zealand hosted Changes to the Earthquake-Prone Building System, presented by EPB. We have a large number of people registered for the webinar, so we're just going to give a minute or two to let everyone join up. For those who are interested, we had over 1,500 people register, and we've just clocked over the 700 participants. So we'll give it another minute or so to allow everyone to come online. Welcome again, everyone, to the Engineering New Zealand hosted webinar on changes to the earthquake-prone building system, presented by EPB. We'll be getting underway shortly. We're just giving some time for all the participants to join. I'll give it about another 40 seconds or so, and then we'll kick off. For those of you who are interested, we had over 1,500 people register, and we have just eclipsed the 800 participants and still climbing. Right, well, I'll make the start, and people will join as they join. So kia ora and welcome everyone. Ko Richard Templar, Toki Oinua, ko Kai Whakahaere, Te Arangaho Engineering New Zealand. I'm Richard Templar, I'm the Chief Executive of Engineering New Zealand. It's my great pleasure to welcome you to this webinar on changes to the earthquake-prone building system. A big thank you to Chris and Ken from EPB for their willingness to present and their openness to making sure the sector understands what has happened and is well informed. A big thank you to the technical groups for the leadership they've shown in this space, CSOC, NZGS, NZSEE, and the Timber Design Society. So what is going to happen is I'm going to hand over to Chris and Ken, who will present on the changes, and then Stuart Oliver, President of CSOC, will run a question and answer session. We would invite you to put your questions in the Q&A function. So if you drag your cursor down to the bottom of the screen, you'll see a Q&A. If you click there, that'll pull up a window. If you put your questions in there, then Stuart will be able to go through them and ask the questions. And we have enabled the facility for people to upvote the questions. So that way, if you see a question, you think, hey, that's a question I want to know the answer to, please upvote it. This is the first webinar, and what we expect will be a series, and it's aimed to keep you informed as the policy developed. So we're just about to hit 1,000 participants, and I'll now hand over to Chris and Ken to present.
Good afternoon, everyone, and thank you, Richard, for the introduction. My name is Chris Hubsher. I'm a Principal Policy Advisor at EPB, and I work alongside Ken Elwood, a Professor of Engineering here. And together we're going to take you through the government's proposed changes to the earthquake-prone building system, or as we have come to call it, the EPB system, and we'll be using that acronym a lot as we talk through this presentation. Many of you will be aware that the EPB system has been under review for a little while. In fact, that review commenced in 2024, last year, and it was actually brought forward. Originally, the legislation was supposed to be reviewed 10 years after implementation, which would have been 2027, but the government, on the basis of feedback it was receiving about the performance of that system, decided to bring it forward in case changes needed to be made earlier. When MB was asked to run that review, we realized very early on that this is a really big deal, and it's one of those things that really extends beyond party politics, and certainly the minister, Chris Pink, was really clear that he would like, if possible, for this to be a whole of parliament thing rather than just a single party or coalition issue. And so to that end, when we got this review underway, we set up an independent steering group chaired by Erica Seville, who some of you will have heard of. She recently won the Prime Minister's Award for Best Director. And this review, the steering group included representatives from both the engineering community, but also building owners in the commercial and residential space, and territorial authorities, or TAs, as the organizations who have to implement this regime and make it work in practice. We also commissioned a lot of research. Some of that you're going to hear about today. All of it will soon be available on our website, I think later this week. So if you're interested, please do go have a look, because there's some really worthwhile material in there, and all of it helped inform the decisions that I'm going to be talking through shortly. The final report that MB produced under the guidance of our steering groups already available online, and I think it's a really good read and well worthwhile having a look at. The cabinet paper where cabinet sets its record of the decisions that it's reached is also available online next to that report, and I think it's quite useful to read them together, because you can see the evolution of the policy development as it went through the I guess the ministerial filter and on Pink's lens. Sorry about the delay there. And in short, when we did that review, this is what we found. The system has not been a total failure, and we would never say that, because in fact, 1,500 buildings, EPBs, have either been strengthened or demolished, and that is a big win. However, some would argue that these were probably the low-hanging fruit, because remediating these buildings made more commercial sense than for many others, where it's a much more difficult proposition. And that's the first bullet here in terms of our findings, is that remediating buildings, earthquake-prone buildings, is a very expensive proposition. And for many building owners, it's just unaffordable, let alone uneconomic in terms of the cost benefit, but literally unaffordable. They just don't have the money to do it. And I'll talk about that a little bit more soon. We also found that many lower risk buildings have become EPBs, even though that was never the intent of the system. That's quite problematic for a range of reasons, and I'll spend a bit more time talking about that too. The percentage NBS system, I'm sure you're all very familiar with, and probably quite familiar with its foibles as well as what it's good at. In engineering terms, I'm sure it's a very solid methodology, but in terms of putting it to a regulatory use or a public policy use, it does have drawbacks. And I thought I'd illustrate that with one brief example I've come across recently, which was a 2023 High Court case, CAD Management Limited versus the Ruth Viner Family Trust, where a building, the same building at roughly the same time, received 4 NBS scores. And that was actually what the litigation was over. And those NBS scores were less than 10%, 30%, 43%, and 60% NBS. And all of these scores were calculated by reputable, experienced engineers. So I think when that can happen, there is a bit of a problem, and Ken will spend more time talking about that. The enforcement tools are difficult for councils to use, largely because it involves going to court, which is always an expensive and slightly risky proposition. But I think one of the main issues with the enforcement tools from the territorial authority perspective is that they can do it maybe for a small number of buildings where they need to enforce some kind of remediation once a building has passed its remediation deadline, but it's really impossible to do when you're faced with a really large number of buildings that have passed their remediation deadline, because like I said, litigation is expensive and it's just too much of an impost on ratepayers to have to deal with a really large number of cases where the council is trying to enforce some level of remediation. And finally, we have heard quite strongly from a range of people that heritage restrictions do make remediation both more expensive, but also just more difficult in terms of the compliance barriers to do with the resource consent process and everything that's involved in that. I'm just going to jump to a couple of case studies to help illustrate what I've been talking about in these bullets. Here's one case study which is taken from MB's report, which again you'll find online on our website. A small computer shop in Dannevirke, where the owner built it for 50 grand, but then later on found out that the strengthening work that was required for that building, being an EPB, was 200,000. Even demolishing it would cost more than what the owner actually paid for the building. And unfortunately, you can see the same situation all up and down main streets across provincial New Zealand. This is not an isolated case. This is actually quite a mainstream problem that provincial centres in particular are having. And here's another case study which I decided to use at the risk of making myself slightly unpopular with some in the engineering community, because I think it shows how some of the incentive structures built into the EPB system have led to perhaps outcomes that we didn't envisage at the time we set it up. So a fairly typical example, a couple have bought a building with a view to doing it up. They thought the remediation would cost 400,000. It ended up costing 600,000, and this couple, at least in the news article that I read, were blaming at least some on that on over-enthusiastic engineers who were perhaps building in a bit more redundancy than this couple thought was necessary. And there's some interesting points that come through this. And one of that is that there's quite a lot of myth and reality around the EPB system. I wouldn't take all of this necessarily at face value, because another thing that we hear a lot about, which actually isn't the reality, is, as far as I'm aware, is that we hear a lot of talk about shifting goalposts, and the earthquake strengthening requirements are always going up. So what we do now won't hold later on, which just isn't true. And MB hasn't run the system like that at all. But what is true is that some of the players in the system do face powerful organizational and personal incentives to minimize their own risk. And in particular, I'm thinking of territorial authorities and engineers, because if you were to find a building is not earthquake prone, when something happens to it later on and it causes deaths or injuries, that's going to be a really big problem for any individual person. And I guess in this particular instance, what makes it an even more powerful incentive is that whereas the councils and engineers who are assessing buildings need to manage their organizational and professional liability around, I guess, underplaying the risks, they're not the entities that are actually paying the bills. And often, if I have a problem at home, I think, well, I could do this, but it will cost that much money, so I may or may not do it. Whereas this doesn't play out in this way in the earthquake-prone system. One set of players are, I guess, imposing requirements, and another set of players are footing the bill for that. And that can lead to quite interesting consequences, which you're going to be seeing on your screen around now. These are what we call non-profile category buildings, in that they are not unreinforced masonry and they're not multi-story concrete buildings, nor are they pre-1935, or at least most of these. I'm not sure about the bunker there, are pre-1935 buildings, but all of these have been found to be earthquake-prone buildings. And I want to emphasize again that I guess when the framers of this law looked at these buildings back when the law was passed, that never would have crossed their mind ever that these kind of buildings would be found to be EPBs. That was never the intention yet it's happened, and it's happened a lot, as I'll shortly show you. But just before I get into that, there's another set of buildings that I think have been slightly overlooked in the operation of the EPB system today, and that's buildings that perhaps could have got exemptions from the requirement to undertake seismic work, but haven't received those exemptions. And what you're looking at now is a building in one of my favorite places, which is the Wellington Botanic Gardens. This is the old stables where they used to keep the stables for the horses and carts. Now it's basically a tool shed, yet it's an EPB. And as things stand, it's going to have quite an expensive amount of remediation, even though I happen to know from walking past it a lot of times that this building's in a cul-de-sac and no one ever goes there apart from people getting out the tractor. I think it's a useful example of a wider problem in that we have these exemption provisions, but councils are reluctant to use them for fear of the organisational risk that I've been talking about. And also many building owners don't even know that these exemption provisions exist. And the cumulative result of all of these incentives and the way that the system has been playing out is that you've got non-profile category buildings making up over half of all of the EPBs in New Zealand. Whereas I suspect that when the framers of this legislation thought about how it might work out, they probably thought that non-profile category buildings would be less than 5%. But that's not the case. They've gone up to make more than half of all of the EPBs in New Zealand. And addressing this issue is at the core of the proposed changes, which I'll shortly get to. But I just want to dwell a little bit more on why this is actually a problem. And it's not just a problem because of the unexpected and high costs to the building owners, but also because it's creating a lot of uncertainty in the property investment market. And that's not a good thing at the moment of all times. The reason for that uncertainty is a lot of property investors or would-be property investors are looking at a property and going, yes, well, maybe it's not an EPB now, but how do I know in 1 week's time, 6 months' time, 2 years' time, it won't be an EPB. So no, I'm not going to invest any money in that building. I'm not going to do it up. I'm having nothing to do with it. And you can imagine that all of those people saying that all up and down the country is actually impacting on the use and investment of property types in New Zealand. So in light of all of these issues, here is what the government is proposing in terms of solutions. Firstly, only two kinds of buildings will be able to be EPBs, and they are unreinforced masonry, which is profile category 1 of the current profile categories, and multi-story, that is 3+ story buildings of concrete or heavy construction, which is profile category 2. Profile category 3, which is the pre-1935 buildings, is taken out of the system, so that will no longer exist. And a further filter is that only those kinds of buildings in medium and high seismic zones can be EPBs. So that is to say, any building, any EPB in a low seismic zone will no longer be an EPB, and no new EPBs can be added in low seismic zones. There will be cheaper and simpler mitigation requirements for the remaining EPBs. And when I say cheaper and simpler, I actually mean more cost effective, because they will still manage risk. And Ken is going to spend quite a lot of time talking about how these solutions still manage life safety risk. But one thing I do need to emphasize is that the proposed changes won't come into force until a new law is in place. And until then, the current requirements continue to apply. And this matrix sets out how the new system is going to work. So just to briefly run through it, and Ken will do most of the talking as we get to the detail, but just really briefly. For multi-story concrete buildings, there's going to be a targeted retrofit requirement, and that will apply no matter whether the building is in an urban centre or a rural or small town. Whereas for unreinforced masonry buildings, if they are 1 to 2 stories and they're in a rural area or a small town, they will only be on the EPB register. They won't need a physical notice, and they won't have a seismic work requirement. So they'll have no deadline, no notice on the door, but they will be recorded on our register, and prospective owners or tenants will be able to look up that building and determine its status from our register. Those same buildings, however, if they're in an urban centre, 1 to 2 story URM buildings will require their facade to be secured. And when we talk about facade securing, we're talking about the facade that fronts onto any public space or elements of the facade that are above any neighbouring buildings. That facade securing requirement, again, applies to 3+ stories in rural or small towns, but for the small number of buildings that are 3 or more URM buildings in urban centres, they will require a full retrofit, which is equivalent to the current requirement to get beyond 34% NBS. And in terms of how that plays out in terms of the distribution, you'll see that the majority of buildings, just over 50%, are unreinforced masonry buildings that will require their facades to be secured. Quite a decent number of URM buildings also just go onto our risk register, so their requirement for seismic work is removed and the requirement for them to post a physical notice is removed. There's not that many large concrete buildings that require a targeted retrofit. We calculate over 200, around 220, and there's a very small number of buildings, only about 80 on our current calculations, that will require a full retrofit. So it's worthwhile bearing in mind that the 3% of buildings that require a full retrofit is a reduction from 100% of buildings under the current regime that would have required a full retrofit. In other words, 97% of all EPBs in New Zealand will have changed remediation requirements. There's also a bunch of other changes that we're going to be making, which I'll briefly run through. We're changing the alterations requirements so that a building consent for seismic work and only seismic work that meets or goes beyond the building's remediation requirement will no longer trigger the requirement for concurrent work to meet other building code provisions relating to escape from fire and disability access and facilities. The government is well aware this is quite a big call and there will be voices for and against it, but it actually responds to a recommendation that was originally made by the Royal Commission back in the day. And the reason is that building owners, rightly or wrongly, have reported that they are being put off doing the seismic work because of these additional requirements. And ultimately, it's a question of, well, what will save lives here? And so the government is looking to change those requirements, but only as they apply to earthquake-prone buildings, not for any other buildings, only earthquake-prone buildings. Just in terms of change of use, when an EPB is changing its use, instead of needing to be as near as possible to the relevant building code standard, it will only need to meet its mitigation requirement. And importantly, where that building is a 1 to 2 story URM in a rural area or small town, the mitigation requirement is just to be on the EPB register. So there will be no requirement for seismic work. The Identify Anytime pathway, and remember that this pathway is how all of those non-profile category buildings were brought into the EPB system, the 55% of buildings that make up the current complement of EPBs. It's going to be narrowed. So in future, it will only capture buildings that are 3+ story concrete or heavy construction that were constructed post 1976. And this obviously carries on from profile category 2. So you've got profile category 2, which is a 3+ story buildings built before 76, and then the Identify Anytime pathway captures that same kind of building that was built after 1976. One other limitation, which I didn't have room for on the slide, is that the Identify Anytime pathway will only be available for buildings that were constructed before this new legislation comes into effect. So there is a cutoff date, and any buildings that are constructed after this bill comes into effect won't be able to be made EPBs under this pathway or any other pathway. Another change is that priority building status, which the effect of is to halve the remediation time, or the time that's available for remediation, is going to be removed from EPBs that don't stand a chance of falling on people or vehicles, or don't impede access to key emergency facilities. What this means in practice is that a lot of schools, clinics, fire stations, things like that, that were made priority buildings because of the kind of building that they are, or the function that they have, they will no longer be priority buildings. And the reason for this simply is that the government's position is that it's up to the relevant departments or ministries that run those buildings to sort out their remediation, and they expect that to happen in good time, but not necessarily in line with the deadlines for priority buildings. And finally, one very big change is that the percentage NBS system will no longer be used to identify EPBs. Instead, any URM building will be deemed to be an EPB by default unless it's already been retrofitted or the TA has already written to the building owner saying that this is no longer an EPB, in which case it will remain no longer an EPB. And multi-story concrete buildings, they will be evaluated for EPB status through a review of deficiencies. And that review of deficiency is at the very core of the methodology for targeted retrofit, which Ken will be talking to very shortly. So just on the timeline, the government has a very ambitious agenda for this bill. The minister's told us very clearly that he would like to see this bill passed before the House rises for the election next year. So that it's likely to be around September, or if all goes to plan. And the bill would commence, that is, all of the changes that I've been talking about will actually come into effect around mid-2027. What this means is that the opportunity to comment, and we sincerely hope and encourage everyone who's watching here to review the bill when it comes out and make a submission to the Select Committee. That's likely to happen early in 2026, and it will run between 4 or 6 months. We're not quite sure about that yet. Right, so that's the end of my part of the presentation. I'm now going to hand to Ken, and Ken will be talking about how we actually arrived at this current policy proposal and the kind of thinking that's gone into it.
All right, thank you very much, Chris. Glad to see so many people registered here online. I really felt quite privileged to be involved with this effort here at MB. And I hope I've taught Chris as much about engineering as he's taught me about policy in this process. So I'm here to talk a little bit about the background of how we arrived at the recommendations that Chris has just outlined. And essentially, like any good program, we should start with what's used elsewhere. And so Quake Core actually did a nice study for us on lessons from other countries where they've implemented seismic mitigation programs. This report is available like the other reports for you to access from our website. It's a very good read. I just want to highlight a couple of aspects that are particularly relevant to where we ended up. First of all, if we look at these programs internationally, they tend to focus on one building type at a time. In the case of California, where these are city level ordinances, they are specific ordinances for specific types of buildings, unreinforced masonry buildings or older concrete buildings. In Japan and Taiwan, the programs were really just focused on those older concrete buildings. Whereas here in New Zealand, we basically built a system that could address all buildings, as long as they had low ratings. So we probably built in some additional challenges by having such a wide scope. Perhaps there's some advantage to these systems that focus on specific building types. Another interesting aspect looking abroad is that none of them use a rating system similar to percent MBS in identifying what buildings are considered within the seismic mitigation program. Instead, as I indicated, the programs were building type specific, and the criteria for what buildings were included within the program was very prescriptive. Essentially based on the date of construction and specific structural characteristics. A couple of examples shown there from URM law in California and the non-ductile concrete program starting up in San Francisco. We also noticed that there were a few cases where they specifically developed these sort of targeted retrofits to try to keep the costs of those retrofits down. Two examples stand out. One is in Taiwan, where they focused on weak stories as their primary deficiency within concrete buildings and developed targeted retrofit approaches for those weak story buildings. As well, the Bolts Plus approach for unreinforced masonry buildings in California is essentially a form of targeted retrofit to address the worst vulnerability in those buildings, which is the unsecured facade. So with that background, then we considered a whole range of possible future state options for the EPB system. And these options ranged from the status quo, the current system, all the way through to fully removing the EPB system, and then many different increments in between. I like to think of this sort of range of options by thinking about a balance between the regulated cost on one hand and the residual life safety risk of the changes on the other hand. Of course, as you move from the status quo toward no regulation, your regulated cost is reducing. But as we reduce that cost, reduce the number of buildings within the system, that of course implies that there's a little bit more residual life safety risk with each of those subsequent options. And so really what we're looking for is sort of a sweet spot in the middle, or where you're balancing that cost and life safety risk. If you're a purist and you really want to focus on just the life safety risk, well, then we need to recognize the fact that under the status quo, we're not necessarily getting that full compliance. And so perhaps we also need to lessen off a little bit to try to improve that compliance and maybe the life safety risk when we consider the barriers to compliance. Maybe actually the life safety risk is generally similar across several of these options. But what we're really trying to do here is look for that sweet spot where we balance off the cost and life safety risk. And where we ended up is a system which is risk focused or risk based. And risk, of course, is has three fundamental components. There's the seismic hazard, there's the building vulnerability, how vulnerable is the building to collapse and severe damage in an earthquake, and then the consequence, or in other words, the human exposure to that damage in the building. And it's really the combination of these three that forms your risk, your life safety risk. And so you're probably all familiar, of course, with risk matrices. Well, with three different components, we need to really make you might call it a risk Rubik's Cube. And what we really want to do is focus in on that orange block in the bottom right corner, where at that point we've got the highest seismic hazard, the highest building vulnerability, and the highest consequence. That is the worst case, and then perhaps slightly lower risk going out from there. And when we put it in this framework, it poses natural questions that the team needed to address. First of all, do we need obligations in those lower hazard zones where the risk is naturally going to be lower? Perhaps we can focus on the most vulnerable buildings. In other words, the unreinforced masonry and those high-risk 3+ story concrete buildings. And perhaps we can have a relaxation for buildings where there's typically going to be lower human exposure, and perhaps a proxy for that is small buildings in small towns. And so it was all of these questions that sort of came together to form our the proposal that's been put forward by the government. First, let me just address the seismic hazard aspect, and then I'll come back to this risk cube to talk more about the mitigation actions. So the first decision was by the government was to remove the low hazard zone from the EPB system due to the lower risk that is posed there. If we look at the current map of the seismic zones, you'll note both a low zone in sort of north of the Bombay Hills, if you will, and coastal Otago. But we know that we've learned a lot about seismicity since the time this map was drawn based on the 1170.5 2004. So if we redraw that map based on new understanding of the seismic hazard from the National Seismic Hazard Model and what is incorporated within the TS, which is due to be released shortly. We notice that the seismic hazard in coastal Otago is really not as low as Auckland and Northland. And so it was based on this that there was the decision to move coastal Otago to a medium zone. But otherwise, the boundaries between medium and high seemed reasonably close enough. And so the boundaries were all left alone, with the exception of simply moving coastal Otago to a medium zone. So let's now come back to this risk Rubik's Cube. And it seems fair that in the lower risk areas and lower risk conditions, we might have no mandatory mitigation requirements, whereas in the highest risk conditions, we require full retrofit. And what about that intermediate point, that intermediate risk? Well, that's where we land on this concept of targeted retrofits for an unreinforced masonry building. This would be facade securing. That provides you that sort of intermediate level of protection that's commensurate with the risk that those buildings pose. So let me walk through what these different retrofit requirements would involve. So first off, for URM, you've got the facade securing, and essentially we're trying to address the sorts of damage that you see time and time again after past earthquakes, as is shown in this photo, where essentially what we're trying to do is just restrain the walls facing onto public spaces or above adjacent properties, restrain it back into the diaphragm. And we see that this type of approach, we can get approximately an 80% cost savings over a full 34% retrofit. So that's quite significant, particularly when you think about the sheer number of these buildings across the country. However, when we start getting up to above 2 stories, 3+ stories, then actually the buildings and the vulnerability is quite a bit more complex, and the risk is higher. And so there we require a full retrofit, and that is to address all of the high-risk deficiencies within the building. It's essentially a similar cost to a 34% retrofit. And there it's not just sufficient to restrain the facade. When we come to concrete buildings, we want to take this targeted retrofit approach of where we target these highest risk deficiencies. Really, what we're looking for is the biggest bang for buck, the greatest risk reduction per unit cost. Okay, and the exact level of cost savings you're going to get is going to vary. And it's going to vary quite a bit, but on average, you might get about a 20% cost savings for a targeted retrofit. As I mentioned before, this Taiwan has implemented a program like this called their Weak Story Retrofit Program. This image here shows a building in the background that has a brace in the window where clearly it has been retrofitted and survived the earthquake, whereas the building in the foreground was not so fortunate. And so it's a clear visual demonstration of the benefits of such a retrofit approach. Now, these targeted retrofits need to target these high-risk deficiencies. And so let's talk about those next. You'll notice that we talked about the system as targeting only the high-risk 3+ story concrete buildings. While a high-risk 3+ story concrete building is a building with high-risk deficiencies. And so you might ask, well, what is a high-risk deficiency? Well, unfortunately, I can't give you a definitive answer on that right here and now, as we're still working through the details of what exactly is going to define a high-risk deficiency, but this will form part of the methodology. I show here a few examples of buildings with high-risk deficiencies. Of course, some of the examples from Christchurch there, obvious, the CTV building. Often, one of the characteristics of buildings with high-risk deficiencies is that it's a combination of a deficiency within a component and a deficiency of the entire building that drives the demand on that component. So the example of CTV, you might say that component is a non-ductile column, and the building characteristic that drives the demand on that column to make the drifts high on that column is the torsional response of the building, with the core being set outside the plan of the building. You've also got the Smith's car park, where you've got non-ductile slab column connections in a building that is going to drift a lot with essentially only a slab column frame as its lateral resistance. And so those large drifts combined with the non-ductile slab column connection, that gives you that high risk deficiency. PGC, you've got a vulnerable non-ductile wall along with, but that wall actually, the core for that building is actually quite weak in relation to the demand on the building. And so that exceptionally weak lateral system combined with the non-ductile wall can lead to a concentration of damage in such a building. So it's these sorts of combined component characteristics with system response that we're looking for in these buildings with high risk deficiencies. So these will be compiled, these will be defined quite prescriptively within the EPB methodology, and we're working through that process right now. A building that does not have high risk deficiencies, though, can be removed from the register. So that means that some current EPBs, 3+ story concrete building EPBs, which do not have these high risk deficiencies, actually may be able to come off the register. A feasibility study has explored the application of this approach and has looked at applying the concept to about 20 buildings that had percent MBS less than 34%, and it was found that about 10 of those buildings actually did not have high-risk deficiencies and therefore would have been able to come off the register. So as you can see, this is still a work in progress, but we're quite confident in the direction this is all going to give us a good procedure for identifying these high-risk 3+ story concrete buildings. From all of this, though, there will be residual risk, right? We're taking some buildings out of the system. We're taking some vulnerabilities out of the system, so 1- and 2-story concrete buildings or masonry or reinforced masonry buildings will not be captured. There will be some residual risk there. If the building is only vulnerable, only identified because of its lateral system, but there's no failure of a vertical load bearing element, then it could potentially be removed from the EPB register. And buildings where it's only secondary structural or non-structural systems which are triggering the EPB status, those would no longer be EPB. What all of this emphasizes for us is the importance of maintaining a voluntary mitigation alongside our mandatory system, the EPB system. And I'll come back to that point in just a minute. I just want to talk in the next couple of slides about some transition aspects. Um, as you're all aware, we currently have 3 profile category buildings: Category A, Category B, Category C. And then we have this anytime pathway where any other building, there are some restrictions, but essentially any other building can be identified through this anytime pathway. In the new system, we're carrying over largely the definition of Category A, and we're carrying over the definition of Category B. Category C is no longer considered within the system. This is largely because of the 1 and 2 stories, lower risk, lower exposure, but as well, those pre-35 non-URM buildings tend to have smaller bay lengths, more columns, less vulnerable. But then you'll notice that under the anytime pathway is quite a bit narrowed compared to the current system. The anytime pathway is only for those post-76 buildings of heavy constructions, 3+ stories. Further to this sort of transition from the current system, one other point was you might just ask, well, we've already identified a lot of these profile category buildings, and indeed we have. In fact, iZone has essentially finished the identification of all the profile category buildings. Medium Zone is nearly finished those identification of profile category buildings. So we're really working with what's already on the register. It's really only in Dunedin and Coastal Otago where they will need to continue to identify these buildings, and they have until 2032 to do so. The post-76 buildings would only be identified through this anytime pathway, which is a similar pathway to what we have today. Now let me talk about one other transitionary aspect, and this is how we move from the buildings that are on the EPB register today to the future EPB register. And essentially, we're going to take this in 3 steps. So the first step will be at Royal Ascent to remove any buildings in Auckland and Northland, as they're no longer part of the system, and that's quite easily done. Then we're just left with what's in the orange box there. And then we'd propose that at commencement, that all buildings other than the unreinforced masonry or the 3+ story buildings of heavy construction in high and medium zones, all other buildings would be then removed at commencement. Then finally, after commencement, we'd focus in on those high-risk 3+ story concrete buildings, and there would be the opportunity to remove buildings that do not have those high-risk deficiencies. So sort of a 3-step process to getting down to the final updated EPB register. And of course, buildings in, say, Dunedin or Otago that are identified in due course would be added to this updated register. So what is the future of percent MBS and seismic assessments? As we've said, and Chris identified that percent MBS will no longer be a specific feature of the EPB system. Buildings will either be EPB or not EPB, and buildings will be identified as being EPB based on their structural characteristics. That is to say, whether they have these high-risk deficiencies. These high-risk deficiencies will be identified by engineers by a specific process laid out by the EPB methodology. But identifying those high-risk deficiencies will draw upon information that is contained within prior seismic assessments, such as DSAs. So those assessments are still definitely very much of value. It is expected that there will be some demand still for assessments outside of the EPB system, perhaps via percent MBS or perhaps a replacement. Just in terms of what this could look like, the current system, of course, defines EPB based on that percent MBS. The proposed regulatory system that we've just been talking about is binary. You're either EPB or not EPB. But there's a need perhaps still to consider performance across that range of non-EPB buildings. And one possibility of a system that could be defined by the market might be sort of a categorical system for those to define those non-EPB buildings, where you could imagine the securing of URM facades and targeted retrofits for concrete buildings might just slot in there under D, but you want to recognize if somebody wanted to retrofit to a higher level. Part of the advantage in my mind of having some sort of a categorical system like this is you could also have some sort of risk-based adjustments that move a building from one category to another, depending on the characteristics, the risk characteristics of the building. But all of this is yet to be defined, and really is something for the market to define. It is not part of the regulatory system. It is not something that MB intends to define. And many of you have seen me show this slide before. It's a nice sort of diagram of the overall building regulatory system, ranging from the earthquake-prone buildings right through to new buildings, and recognizing the fact that actually a lot of the buildings out there of our existing buildings actually are in this is in the space in between. Essentially, the changes that we've just talked about here today keep the same structure. The only thing that we're doing is we're shrinking and changing the language a little bit for that earthquake-prone section. And so it's now specifically based on the building characteristics. That does mean that there are some more buildings entering into that orange box in the middle, and it just emphasizes again the importance of thinking beyond just simply how we approach earthquake-prone buildings. But I encourage the profession to be thinking about how we approach buildings outside the earthquake-prone regime. And with that, I come back to this the schedule that Chris shared earlier. You'll notice a couple of dates to bear in mind here. First of all, expect to be going to select committee in 2026. This will certainly be an opportunity to comment on the system. And the engineering guidelines, which would support the implementation, will be developed as we go along, and expect them to be available sometime, let's say early 2027. And there'll be opportunity to comment on those as well prior to publication. So I think with that, we open it up for questions.
Right, thanks, Ken and Chris. So we'll crack into the Q&A. So I guess there's a few things to cover. We're going to start with the questions that were submitted to Engineering New Zealand when people registered for the webinar. I guess a couple of things to note, as sort of Ken and Chris have sort of mentioned this morning, the system's still being developed, so we haven't, not all the systems, sorry, not all the details have been finalized yet, so there could be some questions that Chris or Ken may not be able to answer, so please be aware of that. And if we run out of time and we don't get through all the questions, Engineering New Zealand will forward these on to MB so they can be included as they develop the policy further, so they won't be forgotten about. So we'll crack into the first few written ones. So the first one is, between now and implementation, should owners and engineers proceed exactly under the current EPB framework, including ISA's, DSA's to the 2017 assessment guidelines, and will MB issue interim guidance to keep work moving?
Thanks, Stuart. The short answer to that is yes. We should carry on using the current framework. And the reason for that is because the proposal to change the law is only that. It's only a proposal. There's a very long way to go before that what you're seeing here becomes the law of the land. It may well change on the way through Parliament. These things obviously do. And as Ken just has said, the relevant methodologies are still under development. So work needs to happen in the interim. We recognise that, and it needs to happen under the current framework as it stands now.
Great. I think question number 2. If the percentage MBS is removed from the EPP system, what single nationally consistent metric or grading will MB endorse for communicating seismic performance? And what happens to the existing reports that have used the percentage MBS grades?
Thanks, Stu. As we've said, the regulatory system, the EPB system, which MB is responsible for, will be binary, right? Either it'll be EPB or not EPB, because that's the certainty that we've been told from the stakeholders are looking for. MB will support the market-led approaches to develop some form of holistic building rating system. But at this stage, MB is unlikely to lead such an effort. We'd encourage the industry to lean into that. I can say that the Natural Hazards Commission is interested in supporting an initial effort in that direction in the coming year. And one aspect that I think we do need to be aware of is transition, and the question of how existing percent MBS ratings would translate into a new rating is really yet to be determined. But we believe that considerations of this translation from percent MBS is really important to make the most of where we've gotten to over the last many years of developing our seismic assessment approaches. That's how we land on the idea of development of a rating system.
Thank you, Ken. Question 3, for targeted retrofits, for example, for year-round facades, precast systems, or building vulnerabilities in post-1976 concrete, what minimum analysis or verification will MB require to ensure robust outcomes without a full DSA?
No, good question, Stu. Unfortunately, that is one of those questions where we're not able to give a full answer at this point. The details of exactly what will be required for the design of targeted retrofits are really still in development. MB's focus right now, of course, is introducing the bill, then that then moves on into select committee. So there's a lot of work to be done in front of us. A draft methodology will be developed. A methodology will be consulted upon. So there will be opportunities for engagement by the engineering community and comments to be made when we have those details to share.
Okay, look forward to seeing that. Next one's probably for Chris. Well, section 112, building alterations, and section 115, building change of use of the Building Act continue as they are, including ANARP, and the ability to design for less than 100% MBS justified. And how will MB ensure consistent application across all TAs?
Thanks, Stuart. We are making changes to alterations and change of use rules as described in our presentation, but it's really important to understand that they only apply to EPBs, not to any other building. So we won't be changing those sections. In short, we'll be changing the sections that around alterations and change of use in section 133 of the Building Act, which is all about EPBs and is only about EPBs.
Okay, thank you. The last one, I think we've covered some of it, but there's possibly parts that we haven't quite covered, so I'll read it out before we go on to the live Q&A questions. I think the first up we have covered, which is what is the technical and policy basis for excluding Auckland and Northland from the EPB regulations and reclassifying Dunedin and Coastal Otago? How do these settings align with the NZS 1170 uniform risk intent, and what changes for owners in practice? So in terms of obligations, deadlines, targeted retrofit expectations, and will there be transitional or heritage specific support to manage the cost and insurance impacts? So it's really the second half of that question, I think, around cost and insurance impacts that maybe we haven't addressed in the webinar so far.
Yeah, so yeah, I've already talked about the aspects of why low was taken out of the system and reflection of how the National Seismic Hazard Model informed our choice to move Dunedin and Coastal Otago from low to medium. In terms of your the manage costs and insurance impacts, we are doing an extra piece of work now that looks at additional support and or consideration of support structures for EPB owners. Some of that will consider insurance, but I'd say our focus to date has been on the EPB system changes itself.
Cool. Thank you, Ken. Okay, we'll go to the live Q&A. So as Richard mentioned before, there's a question there that you quite like. Upvote it. We're basically going to work our way down from the top. So the first one is, banks and insurance companies have seemed to adopt the percentage MBS ratings in consideration for insurance and finance. Has there been any consultation with insurance and banks to ensure they don't hold building owners liable to the same percentage MBS requirements despite the change to the EPB legislation? So I guess the question really is how much consultation have we had with banks and insurance companies about what has been proposed?
Thanks. It's a great question. We recognise that the way that the finance and insurance market works in New Zealand is a whole additional barrier for EPB owners to getting them remediated. To be blunt, however, it's not really within our control within the regulatory system. We have spoken extensively with banks and insurance companies, and interestingly, they've actually told us a range of things. Some of them say, "Oh no, we don't use NBS at all. Just don't use it. We've got our own metrics that we use for the seismic risk of buildings," whereas others will say, "Oh yes, we definitely use NBS." And more will say, actually, we quite like NBS, but we'd like a more robust and more holistic scale. So if you could come up with something, that would be great. So yes, they do have their own requirements. To be blunt, we can, try and jawbone the banks and insurance companies into adopting a more facilitative approach to finance and insurance, but that will only take you so far. So I guess it's probably realistic to say MB is first and foremost focusing on changes to the regulatory system, which is our remit to do. And we will certainly look to work alongside the banks and insurance companies to address those other barriers as we can, but realizing that there's no regulatory lever we could ever employ there.
Thank you. Next one's probably with Ken, potentially. Two-story hollow core floor buildings with inadequate seating do not appear to be considered as an EPB. Can you explain the reasons for that, Ken? Or I assume that you can answer that question.
Yeah, so that's quite right. And I mean, there's a couple aspects to this. First, that a two-story building will typically not get the drifts that would cause a concern for a hollow core floors in the first place. And secondly, is that we're looking at these high-risk deficiencies that are really focused on the overall building vulnerability and really the potential for collapse. And so isolated floor unit failures does not really fall within that scope of what is a high-risk deficiency. So for both those reasons, it would not such a building would not be considered an EPB.
Okay, thank you. There's one here. We should still have a standardized way of measuring the seismic performance of buildings outside the EPB framework. Will the current assessment methodology continue to be maintained as essentially New Zealand's version of ASC 41? Would MB continue this, or will this methodology be handed back to NZSE?
I would be a strong proponent for maintaining the seismic assessment guidelines. The DSAs will be needed in different formats. Exactly how they'll be maintained, whether it's MB, whether it's NZSE, whether it's another entity is yet to be determined. But certainly there's a wealth of really important information within those documents which cannot be left unattended.
Very good. One here about, in many cases, buildings are a combination of materials. How was this effect addressed here? So I guess things might be a steel frame building with concrete floors and maybe an infill facade or something. So there's a lot of focus on concrete, and there is this kind of, I guess, there's a vague term, heavy. So how far does this extend in terms of different material types?
Yeah, no, good question. Yeah, the heavy construction is essentially a term intended to say it's not interested in timber construction. Most of the vulnerabilities that we're concerned about, most of those high-risk deficiencies that we're concerned about are in concrete buildings or in largely concrete buildings. But there is a recognition that yes, of course, a lot of buildings are somewhat mixed systems. But if they don't contain the one of the high-risk deficiencies, then they will not be EPBs.
There's one here around hollow core again. Should all hollow core double T buildings still be considered for high-risk construction, regardless of the number of stories, especially given the number of failure mechanisms? I think we've partly covered that, but
I mean, I will note that a lot of the issues around precast floors have really come to light as a result of the publication of the yellow chapter. The yellow chapter is not part of the current EPB system. So really issues with regard to precast floors are similar to what they are currently. They're not generally EPB.
yep. Cool. This is quite a interesting one. How would a basement be considered in a 3+ story building?
Yeah, so some of those details are still to be worked out, but generally a basement would not be considered as part of the number of stories. But the details on what exactly is a story, where you count the stories from, and whether or not there's a height limit as well that associated with that story limit, as our current categories have, and where that's counted from and to. Those are all the details that are currently being worked through for the draft methodology.
Okay, thank you. We look forward to seeing those. Using design dates as a proxy for SAFE, in inverted commas, assumes the building has been properly designed to the code of the day. Is EPB going to provide a regulatory pathway to address buildings that were non-compliant when they were designed, consented, and built?
Do you want to? All right. First of all, never use the word safe and unsafe. That's not what this is about. And it's the EPB system is really just about the highest risk buildings. But in terms of the question, that's really something outside of the EPB system, and our focus has been on the update of the EPB system. But certainly issues with buildings that weren't compliant at the time they were consented need some consideration in the future. It's just not part of this work.
Okay, very good. One here around importance levels. Will building importance levels be taken into account when looking into requirements for strengthening?
So the details of that would be covered off within the retrofit requirements, and those retrofit requirements are still in development. But the focus of the EPB system and the focus of the retrofits is on life safety. So it will be about the life safety aspects. So it would be unlikely that you would be retrofitting to a full IL4, for instance, level.
Okay. On here from Jeff Banks. Why no notice on the door of EPBs? Shouldn't users be informed to make a choice?
Thank you. I think that the reason for that is simply because if there's no requirement for remedial work, the notices are likely to be up there forever, and they'll physically decay over time, and then it will be the council's responsibility to go checking these notices, and it does create more work for councils and building owners at a time where I think most people would say realistically having physical notices on buildings doesn't really make that much different to the building's use or traffic. It may initially, but over time, as people become accustomed to them, it's just another bit of paper on the wall that you walk past on the way in and out. And it's for those reasons that the government's made the call that if there's no requirement for remedial work on the building, there won't be a requirement for a notice.
Thank you. Here's one. Won't the changes result in critical construction and design issues being overlooked in non-ERM buildings? I guess this is the concern around the concrete buildings.
If those critical construction issues result in a high-risk deficiency, then they would not be overlooked. There would be a pathway to address those. If they do not result in a high-risk deficiency, then they would not be part of the EPB system. There may still be a risk there, but it's a lower risk.
Right, okay. And there's one here in relation to the Health and Safety and Work Act. So it's been signalled that I think the changes that the Health and Safety Act will be updated. Beyond that point, is that happening at the same sort of timeframes as the EPB policy changes, or is that a separate piece of work?
It is a separate piece of work, and I'm not really able to speculate on the timeframes that it's running to, but what I can say is we envisage a future in which these two pieces of legislation are very well aligned in that there's minimal overlap between the two. And I think that's the problem at the moment is people aren't quite sure where the Building Act stops and where the Health and Safety at Work Act starts. And there may be cases where the Venn diagrams overlap. We want to remove that overlap. So it's really clear that when you're talking about the seismic stability of buildings, you look to the Building Act, you don't look to the Health and Safety at Work Act.
Okay. There's one here around precast panels. The approach to secondary structures suggests that precast concrete cladding panels will not be subject to the EPB system. on multi-story buildings that could present a significant life safety risk to people outside the building if the detailing wasn't adequate, but there is no requirement to improve secure. Yet URM facades, with some exceptions, will need to be secured. Is there an inconsistency here?
Yeah, great question. I think the distinction here is in relation to the level of earthquake that would likely cause a URM facade to fail versus the level of earthquake that may cause the precast panel to fail. Both perhaps expose the public to a risk, but because the level of earthquake causing the precast panel to fail is perhaps higher, the overall risk is lower. And there's also the challenge of identifying exactly what buildings have those precast panels that are of concern because of often being related to construction defect as opposed to an unreinforced masonry building, where if it's an unretrofitted unreinforced masonry building, you clearly know that it is vulnerable to that facade becoming unstable.
Thank you. One here from Dion Marriott. Chris stated that URM would be EPB by default, but also stated that buildings that TAs have already notified owners that their buildings is not an EPB will remain non-EPB. Is it correct to state that any URM that has already been assessed and deemed not URM by TA? Oh, hang on, does that make sense? Sorry. Is it correct to state that any URM that has already been, oh, hang on, my list is moving around. Hang on a second here. Is it correct to state that any URM building that has already been assessed and deemed not URM by a TA will remain non-EPB?
There's potentially two questions there, so I'll address them separately. If a URM building is agreed to be a URM building but has also been secured or remediated, and the TA has sent a letter to the owner saying, thanks for doing that work, this is no longer an EPB, that building will remain no longer an EPB. I think if there's a question about whether it is a URM building at all, and the council has told the owner this isn't a URM building, I see no reason why that wouldn't carry over.
Okay, thank you. So I'm just trying to find some more popular versions. Okay. Consider a 3-story URM building in Wellington, in the Wellington CBD that was strengthened approximately 30 years ago with the addition of a new lateral resisting system, which were not designed to carry the full seismic load. Under the proposed system, should this building still be classified as a URM requiring full strengthening, or should it be considered as a heavy building requiring only targeted strengthening?
Interesting question. I think that the way things are laid out is that this I think as the question posed, the retrofit was pre-2011, in which case the building would be considered URM. If it's a 3+ story URM, then it would require a full retrofit. In doing that full retrofit, you would consider the capacity of the existing structure. So you could take a look at that existing retrofit and determine how much of value you can get from it. And perhaps the retrofit for the building would actually be minimal because of that existing retrofit.
Okay, thank you. There's a few around why Auckland and Northland have been removed. So I'll just read one of those out because I have already touched upon it. If I can find it, here we are. I don't understand why Auckland and the North were excluded. Sure, they're in low seismicity areas, but they were also designed to lower levels. Even if the seismic event is smaller, a UMB that would still need to achieve the same level of reliability as one in Wellington.
The reason why Auckland and Northland have been removed is simply due to the frequency of earthquakes and the lower probability of earthquakes causing the level of damage that the EPB system is intended to address. And so with that lower probability of having the earthquakes that would cause that damage, it was felt that and based on a benefit cost analysis that was done, the benefit cost ratio was actually quite low. It was only about 0.3 for Auckland. It felt disproportionate with the risk to require the same mandatory mitigation requirements in Auckland and Northland.
Okay, thank you. Here's an interesting one. I can just find it again. Sorry, my list is jumping around. Something along the lines of, if this was good enough for the existing buildings, this system, why don't we roll it out for the new ones? I think we're referring to the seismic requirements for Auckland.
Requiring action on existing buildings, like a mandatory requirement action on existing buildings, is quite rare, right, within our regulatory system. That stick needs to be wielded very carefully. Whereas when you are designing a new building, it's much easier to design it right in the first place. And so it's best, the way we're going to build the most resilience in our communities is by taking into account our latest knowledge in the design of new buildings. Whereas imposing that on on existing buildings is a huge cost, and in the case of Auckland and Northland, it was disproportionate with the risk.
Cool, thank you. I found one that, let me just see if I can find it again. It was regarding, where is it? Yep, it's from James Carter. Can you please discuss what is envisaged when non-EPB buildings within a low seismic zone undergo a change of use or substantial alteration?
In that case, there'll be no change from the status quo requirement, which is add up to the building code.
Great, thank you. So from Hamish McKenzie, do you have a 3+ story building definition? When might that be published?
That would be published when a draft of the methodology is released. But I can say that take a look at category B of the current methodology, which is defined as 3+ stories, and it is expected to be similar to that. But the definition will be available for consultation when we have the draft methodology available toward the end of this year.
Great, thank you. There's one here sort of around non-building structures. So an example here was maybe a brick chimney over 2 stories high. Are those sorts of structures going to be captured under the system, or does it have to be a building?
That's a really important question, and something that we didn't cover in the presentation. So thanks to whoever asked it. We won't be looking at individual building parts in the new system. It will be the whole structure. So the whole structure will need to meet the definition of either URM or the 3+ story buildings of heavy construction. The fact that a building has an individual part that might be at risk, like a chimney, for example, won't be sufficient to make that building an EPB in the future.
Thank you. Right, we've got time for one more, I think, then we'll get to close it. Will power infrastructure buildings be removed? They are all 2-story URM and concrete and have no occupancy, but have post-disaster importance with significant life safety issues. So I guess this is around local government and some of our key lifelines.
So as long as those buildings are within the definitions of unreinforced masonry buildings in medium and high zones, then they would be included. If they're in small towns, then they would be only on the risk register, and there would be no mandatory mitigation requirements. I will note, though, the example that Chris gave of being able to use a pathway to show the low exposure might be an approach for some of those buildings to not need to meet the EPB requirements. Having said all of that, if we're talking about critical infrastructure, the agencies that are managing those critical infrastructures are often thinking well beyond life safety and managing their assets for their function for after critical events. After significant events. And so in that case, they'd be going well beyond the requirements of the EPB system anyway.
Thank you, Ken. Right, with that, we'll wrap up the questions here. So thank you for Ken and Chris, and I'll pass you back to Richard to close the webinar. Thank you.
Thank you very much, Stu. And I'd like to also pass on my massive thanks to Ken and to Chris for taking the time to put the presentation together and also being brave enough to have faced a whole lot of questions. And a big thank you to Stu for fielding all the questions. For those of you who are noting, there was well over 100 questions, so I think he did a stellar job in picking the most relevant. We will keep you informed about this. We'll continue to stay in touch with MB and with CSOC, NZGS, NZSE and TDS to keep you up to date with the information. That'll be information on our website and in Discover. We will be sending out a type form following this webinar to get your thoughts on the proposal and hear what's important to you, and we'll use that to bring you more information. And if you have anything you want to get in touch around, please use the email advocacy@engineeringnz.org. Once again, I want to say a massive thank you to Ken and Chris for both putting the presentation together, being willing to present and also willing to answer questions. It's a really good example of the interaction that can be achieved between government and industry, and clearly signals a willingness for the policymakers and the researchers behind it to listen to the industry and respond to their questions. And I think, to me, that's best practice in development of regulations. So I want to thank Ken and Chris very much. Thank you to everyone who's been online. We peaked at over 1,200 participants, which is fantastic. We look forward to getting more information out to you about this and other key issues. So once again, thank you all very much. Ka kite anō, and have a great afternoon.